Starting in June of 2024, newly manufactured four-head pressure fryers, both gas and electric models, will be built with a new upgraded high-limit system. This upgraded high-limit system will be retrofittable to current four-heads in the field with the older electromechanical high limits. This new upgraded high-limit system will be what you're already familiar with on current LOV models, Evolution Elite, as well as Velocity. This high-limit system will consist of three main components, one being our high-limit reset switch right here, as well as our control module, and last but certainly not least, our high-limit probe itself. The probe for the electric model will be similar to what you've seen before, located on the inside of the vat strapped to the elements just like we've seen on previous models. However, for gas units, this is going to be a little different, where you can see on the right-hand side here where the probe comes in, it looks similar to just a regular temperature probe. However, on the right-hand side, this is our high-limit probe, and this is what we would see on gas units. Each one of these probes will have two reading points, whether it's an electric or whether it's gas. And what that means is we're going to have two sets of wires coming out of each probe for a total of 4 wires. Now over here, like I mentioned, we have our electric probe that you can see is curved a little bit, and over here we have our probe for our gas model, which is completely straight, similar to what I was stating earlier about it looking like a regular temperature probe. Both of these probes work off of DC millivolts, which means that they are thermocouples, and we will cover troubleshooting these in a later section. The high-limit module used in this setup will be the new Gen 2 JWF style high-limit module with the V14 software. For electric models, this will be located behind the control panel in the center of the fryer, located towards the top as shown here. However, for gas models, it will be located behind the control panel on the right-hand side like shown here. These high-limit modules have line voltage supplied to them on L1 and L2 right here at the bottom two terminals anytime that the main power switch is on. A power cycle of the main power switch will have the same effect as the high-limit reset switch. Here at the top two terminals we have a normally open relay that when the power is supplied to it, it will close the relay and allow proper operation. Once the high-limit module has reached its trip point, it will then open this relay and give the fault. Trip point for the electric model is 415 degrees, while the trip point for the gas model is going to be 430 degrees. On the right-hand side, we will have our reading points for our thermocouples coming back to the control module itself. You will have the TC- and the TC+ wires. Keep in mind, these are polarity sensitive, so they need to be hooked up properly. Up here at the top, we have our LED lights that will give flash codes that we can use the manual for reference in terms of those flash codes. The last component involved here is our reset switch. And this reset switch is a normally closed switch, and when it is pressed, it will open the contacts, allowing the module to reset. The position of this switch will be in the original placement as the mechanical high limit was before, which is under the control on the right-hand side like shown here. By pressing and holding this reset switch for at least 5 seconds, we'll reset the high limit module. So let's do a little recap. Remember, for this new high limit system, there's 3 main components: our reset switch, the high limit control module, as well as the high limit probe itself. Now, do you happen to remember what form of measurement we would use to put our multimeter setting to measure the high limit probe? If you answered DC millivolts, then you're correct. What about the trip point for the electric model on the control module? If you answered 415 degrees, then you would be correct. Now here's the tough one. Do you remember if that reset switch was a normally closed or a normally open switch? If you said normally closed, then you would be correct. In this next module, we're going to cover troubleshooting what this system would look like.